Hello everyone, and welcome to part 3 of the Natural Language Processing with Python lecture series. Let's go ahead and jump right to the Jupyter Notebook where we left off last time. Alright, here I am at the Jupyter Notebook. Last time we went ahead and created our bag of words transformer, and we explored an example message and saw how we could see how many times specific word counts show up in each message. We can actually also use the .transform method on our bag of words transformed object and transform the entire data frame of messages. Let's go ahead and check out how the bag of word counts for the entire SMS corpus is a large sparse matrix. I'm going to go ahead and say messages underscore BOW is equal to my bag of words transformer dot transform, and I'm going to pass in the entire message column of the data frame. Let's go ahead and run that. Now again, this may take a while depending on your computer speed, so just be patient if you have a slower computer. Now that we have done that on all the messages, we can say print shape of the sparse matrix, and we can go ahead and grab from messages underscore BOW, the object we just created, the shape, and go ahead and print that out. And we can see we have a 5,000 by 572 rows by 11,425 columns. And we can also check the amount of non-zero occurrences. And the amount of non-zero occurrences is you just call messages underscore BOW, the object we just created. NNZ is the amount of non-zero occurrences. So 50,548 of those are non-zeros. And you can also just check the sparsity if you wanted to by grabbing a formula for that. So I'm going to go ahead and copy this from the lecture notebook, and you can go ahead and do the same. But if you check this out, basically you can just grab in the 100 times non-zero messages divided by the shape or overall number of messages. So the rows times the columns times 100, and that's the sparsity. You can go ahead and run this. And if you run this as shown in the notebook, you'll get a sparsity of 0, and that's because it has this round method attached to it, or round function. If you go ahead and delete that round function, you can see the true sparsity, which is 0.079. And this is basically just comparing the number of non-zeros messages versus the actual total number of messages. And this kind of gives you an idea of just how many zeros there are in your actual matrix. Now that we've done the counting, the term weight and normalization can be done with TF-IDF. Remember, that's term frequency inverse document frequency. And what we're going to do now is use scikit-learn's TF-IDF transformer object in order to do that. Let me go ahead and show you how we can grab that from scikit-learn. We'll say from sklearn feature extraction.text import TF-IDF transformer. And then I'm going to make an instance of this TF-IDF transformer. I'll say TF-IDF underscore transformer is equal to an instance of TF-IDF transformer, and then I'm going to fit it to my bag of words, and then go ahead and run that. And then I will say TIDF4 is equal to that TF-IDF underscore transformer, and I'm going to go ahead and say dot transform, and I'm going to transform that fourth message we did earlier, so this BOW4, just to get an idea of what it looks like for a single message. So BOW4, run that, and then we can say print TF-IDF4. And now I can see we have a inverse document frequency and term frequency relationship for this actual particular message. So we've been able to transform just a simple word count into an actual TF-IDF, so term frequency inverse document frequency. And you can reference the Jupyter Notebook if you want more of an explanation on this. There's a larger write-up inside that notebook that you can go over. But basically, you could just interpret these numbers as a weight value for each of these words versus the actual document. And now what we can go ahead and do is check the inverse document frequency of a particular word. So for instance, if I wanted to check the document frequency of the word university, I could say TF-IDF transformer, and then I can call IDF underscore, and then pass in my vocabulary. So That was the bag of words underscore transformer, vocabulary underscore, and pass in the word I want to check. So for something like university, just a randomly chosen word, I can go ahead and actually grab that inverse document frequency. Now let's go ahead and convert the entire bag of words corpus into a TF-IDF corpus at once. I'm going to make one more object called messages. TF-IDF is equal to TF-IDF underscore transformer dot transform. And now instead of just passing in a single message in the bag of words format, I'm going to pass in the entire thing, which was our object messages underscore BOW. And there are many ways the data can be pre-processed and vectorized, and these steps involve feature engineering and building a pipeline. And I encourage you to check out Scikit-learn's documentation on dealing with text data, as well as the expansive collection of available papers and books on the general topic of NLP, or natural language processing. This is a really large field, and it has many paths you can go down, so if you're interested in it, definitely check out the links in the notebook. But now that we finally have the messages represented as numerical vectors, as we've seen here, we can finally train our spam ham classifier. And we can actually use pretty much any sort of classification algorithms. And for a variety of reasons, the naive Bayes classifier algorithm is a good choice. So I'm going to show you how you can use naive Bayes classifier to start off with. You'll say from sklearn naive underscore Bayes import multinomial NB. So this is multinomial naive Bayes theorem. You can check out the link in the Jupyter notebook for this lecture if you want to find out more about the naive Bayes algorithm. But I'm going to go ahead and create an object spam detect model is equal to multinomial NB, and I'm going to fit this to the messages underscore TF-IDF I just created. And then as a second argument, I want to pass in my actual data, which is messages label. And here we're going to try classifying our single random message and check out how we do. So if I call spam detect model and I try to predict off of TF-IDF4, for instance, I can just say grab that, run it, and I actually just want this first item in this output array, so I'll say 0. It detects that my TF-IDF4 message will be ham. Let me go ahead and check that by grabbing, remember our original data frame was messages. I'm going to grab off of the label column the third, so ham. Looks like we're predicting correctly. So we've developed a model that can attempt to predict spam versus ham classification. And if you wanted to run this sort of prediction on all the messages in our TF-IDF, you could just say something like all underscore pred is equal to spam detect model predict, and then just pass in messages underscore TF-IDF. And you'll notice if you say all pred, now you have ham and spam for all the predictions of all the messages. Now something that's really important to note here is we actually trained everything on our training data. So in this above evaluation, we evaluated stuff on the same data we used for training. And as we know, we should never actually really do that. We should be splitting our data into a test set and a training set. Otherwise, we don't really know the true predictive power of our model. If we simply remembered each example during training, the accuracy on the training data would just be 100%, even though we wouldn't be able to classify any new messages. So the proper way to do this, as we've seen before, is to use train test split. So let's go ahead and do that. We'll say from sklearn cross-validation import train test split. And I'm going to go ahead and make this a little different from what we usually do. I'll actually type these out. I want my message underscore train, my message underscore test, and then my label train and my label test to be equal to the train test split call, and my features are just the messages themselves. So messages and then message. And then what I'm going to do is pass in my messages label. And I'll set the test size to be, we'll go ahead and say 0.3. All right, so we have our train test split, and we're passing in the messages. Let's go ahead and split up our data. And remember, I'm just actually grabbing just the text messages themselves. I haven't actually done the entire process of doing the bag of words and doing the count vectorization, the TF-IDF, etc. And now we basically have two options. The first option is I can grab this training data. If I take a look at this SMS train, that's just a list of all the text. So I would still, sorry about the bad word in that text message, I would still have to grab this data and come up here and repeat everything I just did. I have to go all the way back here, do the count vectorization, do the transformation, and then do the term frequency inverse document frequency transformation again, fit it, etc. And then run multinomial NB. That's one way you can do that. But this is such a common process with text data that what scikit-learn has is a data pipeline feature. And what we can do is run our model again and then predict off the test set by using scikit-learn's pipeline capabilities to store an entire pipeline of our workflow. Let me go ahead and show you an example of how you can do this. And this is basically what you're going to be doing when you actually work with real-world text data. You won't be doing all the steps I just did in the previous two sections of this lecture series because scikit-learn has a data pipeline feature which will save you so much more time. Let me go ahead and show you. I'm going to delete these messages and say from sklearn.pipeline import pipeline. And now we're going to essentially summarize all the steps we just did into a pipeline so you don't have to constantly repeat everything for different sets of data. We're going to make an object called pipeline, and that's going to be an instance of pipeline. And what pipeline takes is just the steps argument. And you basically just pass in a list of everything you want to do. So I have my list here, 2 brackets, and my first item is a tuple. And the tuple takes in the name of the step. In this case, we'll call it BOW. And then what you actually want to do. So remember, the very first thing we did was a count vectorizer with the analyzer being equal to our text process function. So this was the strings to token integer step. So strings to token integer counts. And the next step was take those integer counts to weighted TF-IDF scores. So my next tuple, I'm going to put a comma here. We'll call this, just as a name, TF-IDF. You can really pass in whatever string you want there, but we'll label it correctly. And then I call the TF-IDF transformer, close parentheses. And again, that was integer counts to the weighted TF-IDF scores. And then finally, I actually want to train this on my model. And in this case, we'll call this classifier. The string doesn't really matter, it's just a label for you to reference later. And this is where we'll call multinomial NB. And then we'll go ahead and create that pipeline. And now we can directly pass message text data, and the pipeline will do all our pre-processing for us. And you basically just treat this pipeline model as a normal estimator. So you grab pipeline, say .fit, pass in message train, and label train. And what it's going to do is these 3 steps for us. Instead of having to do it all manually yourself, now you can just use pipeline in order to quickly and succinctly do all that. So you go ahead and then run this, and it will take some time because it's quite a few steps, but it's fitting right now in training to all the data. But luckily for you, you just have to pass in the actual text data. You no longer have to worry about manually doing the count vectorization or the TF-IDF transformation. And once you've done this, you have created this fitted pipeline object. And once you've done that, you can just go ahead and say pipeline, predict, and pass in your test data. We'll go ahead and call this predictions. And then I'm going to go ahead and do a classification report once his predictions have been completed. So we'll say from sklearn metrics import a classification report. And let's go ahead and print that out. So we'll say classification report, pass in our predictions, and then pass in the label test values. We can go ahead and say label underscore test. Let's make sure we're putting that in the right order. So y true, that's label test. Go ahead and run that. And we can see we get around a 96% accuracy or precision and recall, which is pretty good considering that we're just dealing with straight text data. So Python now has the ability to work with text data using scikit-learn for you. So we have a classification report for our model on a true testing set. And there's a lot more than natural language processing than what we just showed here, and its vast expanse of a topic could fill up just several college courses, and I encourage you to check out the resources in the notebook in case you want to discover more about this. This is kind of an entire subfield of machine learning where there's a lot of room for possibility. Now, as I mentioned in this pipeline, you can basically do whatever you want here. So for instance, if you didn't want to use multinomial NB, you could use other classifiers. So for instance, let's say we wanted to do random forest classification on this. We could say from sklearn.ensemble import random forest classifier, run that, and then instead of multinomial NB, we'll go ahead and replace that with random forest classifier, run these all again, and see how this compares against the naive Bayes classification. And then once these are all finished running, you'll end up getting a result that looks like this. So you can see it's around the same, but it actually changed the F1 score and recall for spam. So I encourage you to kind of play around with this pipeline feature. Go ahead and read the notebook. There's a lot more notes on this, but this is probably the most important part as far as summing up everything we did. When you're working with real-world text data, you're not going to do all the steps we just showed you in part 1 and part 2, and at the beginning of part 3. That's really just to lay out what every single step is doing. When you're working with real-world data, you're going to build these pipelines for yourself, do the count vectorization, do the transformation, and then call whatever model you want. And for text data, it should probably be multinomial NB, depending on what you're working with. And then just call this pipeline as if it was the estimator that you created. So pipeline.fit, pipeline.predict, etc. All right. Check out the links in the Jupyter Notebook. There's a lot more resources and a lot more explanations in the Jupyter Notebook since this is such a vast topic. But I hope you enjoyed this small insight into natural language processing with Python. And coming up next, we'll show you your own portfolio project where you'll analyze Yelp review text data. Okay, thanks everyone, and I'll see you at the next lecture.